So we're going to pick up from last time where we left off. We're going to work on two different examples today. Two examples that are going to make you think a little bit more than last time's. Okay, if you remember from last class, we talked about a race car that was reaching a speed of 42 meters per second. We found the distance traveled while the race car was braking. Okay, while the race car came to rest. Today's example, we're looking at a plane. So we have a plane starting at rest. So you can write the words or you can write what you think you need to write down. I'll dictate to you though. A plane is starting at rest at one end of the runway. So a plane starts at rest at one end of the runway. So right away, please, what are you thinking before we continue? What are we thinking right away? Good, initial velocity is 0. Very good. That's fine, no problem. Actually, why don't you crack the windows? If it's not noisy, crack the windows. Because it's cold enough outside. Yeah, that's perfect. All right, so a plane is starting at rest at one end of the runway. Again, very good, Jack. Right away, Jeff. Right away, we're going to have VI 0. It undergoes uniform acceleration. Now, I want to make sure I explain that. Uniform acceleration. Anybody know what uniform means? Consistent or constant. Very good. So when you hear uniform acceleration, it's undergoing acceleration that doesn't change. So it undergoes uniform acceleration of 4.8 meters per second squared. Again, uniform acceleration of 4.8 meters per second squared. And notice right away that you see the units, meters per second squared, it's got to be acceleration, and the word is there. This happens for 15 seconds before liftoff. This happens for 15 seconds before liftoff. Yes, meters per second squared, so the seconds are squared.
The acceleration is 15 seconds long.
Well, the time period that it undergoes is 15 seconds. Okay? So the acceleration itself is not, but the time period that it undergoes. So right away we should have this already to start. We should have this. And then finally we should have this. Okay? Just from what I've given you already. Now, if it's an airplane, think about it, and it's lifting off. So is it speeding up or is it slowing down? Speeding up. So acceleration is going to be positive. Okay? If it were an airplane that landed and it said it's braking or coming to rest, what would you put on the acceleration?
Negative.
Yeah, you put a negative there. Okay, keep that in mind, please. Now, the question says two things. First, what is the speed when it lifts off? Okay, what is the speed when it lifts off? And how long must the runway be in length for this plane to actually take off? Again, what is the speed when it lifts off? And how long is the runway for this to actually work? This is an actual problem. It's how they think about, like, how long does the runway need to be? And then they multiply by what's called the factor of safety. So say the runway needs to be 1,000 meters. We're not going to make the runway 1,000 meters. We're going to make it like 3,000 meters. So just in case something happens, right? They're able to still have more room for clearance. Now, you guys ever seen those things that are called aircraft carriers?
Yeah.
Anybody want to explain what the primary purpose of an aircraft carrier is, besides obviously its name being self-explanatory? Jack?
It's for the ability for planes to take off in the middle of the ocean.
Yeah.
And also like refueling.
Refuel and land. Very good. An aircraft carrier is huge, and it's got a certain amount of distance in length for the runway, so that the aircraft can take off and land. Those are very different. There's not much of a factor of safety there. The pilots need to be ready. To actually ready. Relax. The pilots need to be ready to lift off as soon as they get to the end of that runway, because in that case, what happens if they don't lift off in time? They die. I mean, they don't die. Well, they might die, but they go into the water. It's not like in land where they don't lift off in time, they just keep coasting along the extra runway that's left. Whereas an aircraft carrier, if they don't lift off by the time they exit that aircraft, it's going to just dump a nosedive into the water. So they got to make sure that you have a certain distance in. So this is the kind of problem we're looking at here. We want to know what is the velocity when it lifts off, okay, and how long is the runway going to be. So somebody tell me, before we actually answer the question, what variables am I looking for? Give me one of them, Paul.
Distance.
Good. What do we call that in this problem?
The displacement.
Good. And what variable is that?
X.
Well done. So that's my first thing. Or that's what doesn't matter. Second or first, Jeff? Good. VF. Well done. Okay, again, these problems are not tough. All it is breaking them down. Okay, a lot of students get a little bit perturbed by them sometimes because they see like, all right, I got so much information, I don't know what to do with it. Well, look at your units. Again, velocity, always meters per second. Acceleration, always meters per second squared. It might be kilometers, but it's again a length over a time squared. So that's how you can know right away which is which, besides the words in the problem. Okay, and then obviously times in seconds. Next, we had 3 kinematic equations from last class. We had 3 of them. I'm going to list them on the side so we can choose. Can somebody give me one of them to list? Max.
VF equals VI plus A double T.
Uh,
Good. Well done. That's one of them. Another. You can look. It's fine, Jeff.
Acceleration.
Equals,
Excuse me.
final velocity minus, initial velocity over, time.
Very good. And remember, these two formulas are really the same. Okay, this is an alteration of the other one. Very good. Molly, give me another one.
X is equal to VIT plus 1/2 of A times T squared.
Good. There's one more still, because again, the first one was the same, but those again, we can use either one of those, remember. What's the last equation? Reese. Hold on. It was 2AX. That's a VI there, sorry. Okay, VF squared equals VI squared plus 2AX. So really, we want to look, again, at these 3 formulas for our choice. We can always use this top formula, especially in a problem like last class, because we were solving for the acceleration. So this first formula up here, even though these are variations of each other, it's useful to know the first one if we're solving for acceleration. I'm going to cross it off for now just because we're given the acceleration. Okay? So, take a look. Somebody tell me, which of these should I try and solve for first out of VF and X? And secondly, which of the equations should I use?
I solve for the final velocity.
Okay.
Just,
So which equation, Jeff?
that's, well, yeah, you don't need to use the top one. The final velocity was, velocity, initial velocity plus, yeah.
Well done. Why didn't you use the last one, Jeff? Please tell me.
I mean, you're using square, you're using,
What's missing in the last one, Jeff, that we don't have? What variable beside? We don't have VF. But yeah. If we got X first, say we got X first by using this equation, which we can do. We know time, we know VI, we know acceleration. We can get X. And then if we know X, we can get VF using the last equation. But, as Jeff said, we can get VF just using the first equation. So there's more than one method to do these problems. That's what I'm trying to explain. There's no one right or wrong answer here. I'm sorry. There is a right or wrong answer. There's no one right or wrong method to get at the right answer. Okay? The answer is correct one way or the other, sorry. But the method is up to you to choose. So, we're going to use this. Good. VF equals VI plus AT. So, we start by listing a formula, please. List the formula, please. Again, when you're doing these problem sets, you list your givens. Possibly, if you want to, I would list my unknowns. Then I would list my formula. Then I would solve if I need to. But do I have to solve this for anything?
Yeah.
What are we looking for in this equation?
Yeah.
It's already solved for VF, right? So what do I have to just do at this point, Max?
I thought you used like to do the equation.
Yeah, so what am I doing? Just
Putting stuff in.
good. Just plug the numbers in. Again, if I was solving for t in this equation, I would have to rearrange it first, right? But here I can just solve and plug in. Okay, Jack, help me out.
Okay, so you have VF equals 0 times 15 times
Look, slow down, Jeff. Jack, come back. Look here.
okay,
0 is VI.
yeah,
Okay. Plus,
times
though.
15.
It's plus.
Oh, it's plus. I thought it
That's a
was
plus.
T.
That's a plus.
Oh, sorry. Okay.
It's all right. It's all
So
right.
then plus 4.8 times 15.
And remember your units, please.
Oh yeah, sorry.
And here's how I can check. This is why I'm doing units. There's a reason for it. Take a look. If I have a meter per second squared times a second, this is going to become units of meters per second. And look at these units over here, meters per second. Since they have the same units, I can then add them together, even though 0 doesn't matter, right? And look, I'm looking for velocity, which needs to have units of meters per second. Okay? So our final... Go
What
ahead.
is it, 1 squared the
Yes, but this second here cancels with one of these squareds here,
okay.
and you're left with just meters per second. Okay?
But what about the 0 meters? But you're adding that.
I'm adding it, so it's fine. Again, I'm adding units of meters per second to units of meters per second, so it's consistent. So I got 0 meters per second, and it's going to come out to be plus 72. So 72 meters per second. Okay, that's my first problem, or my first part.
Plus
positive or to the right, you can leave it. It's when you get a negative answer that you need to denote the negative. But if you get an answer that's positive, because your acceleration was clearly positive, then you can just leave it. You don't have to put the plus sign. Okay? If the prompt says to the east, you might want to write the words to the east afterward. All right, next one now. Next one. So take a look. I know VF now. Everybody see that? I know VF. So let's cross this, or let's put the number in now. So we can almost act as if it's a given now. Now, take a look at the last two formulas. Which one should I use to find my x value, Jeff?
Well, I would actually use, it's the same as the x equals, but it's transformed into final velocity squared minus initial velocity over 2a.
Okay. So Jeff, you said, because last class we solved for x in this equation here, you wrote it as VF minus VF squared minus VF squared over 2a. Yeah, we solved this last class. Very good for x. So you can definitely use this. What else can we use also?
Just the second.
The second one also. Take a look at the second one here. The second one has VI, we know that. We know T, we know A, and we know T. And that's already solved for x. So if you didn't want to solve this for x, you can use the second. It doesn't matter though. What did we say last class? Remember? You get the same answer either way.
Would you not put
Okay.
delta?
Delta for the T.
For everything?
Remember last class I said we're going to kind of just drop the delta from this point on in front of the T? Simply the reason being is that if your time period is like 20 seconds as opposed to time going from 30 to 50, it's still 20 seconds either way. Like 30 to 50, that time gap is 20 seconds, as opposed to this, just saying 15 seconds. So what we've kind of assumed is that the delta is there. The T assumes there's a delta. Same thing with the X. There's really a delta there, or a change in displacement. Okay? Very good question, Max. So, again, I would probably use the second one just because it's solved already, but we can use this one also. It makes no difference. Okay, it's completely up to you, whatever you'd like to do. So with that said, let's go ahead and take a look at our answer here. If we want to solve this, and again, we solve it two ways. The first way, x equals VIT plus 1/2 AT squared. X equals, what was VI again, everybody?
0.
So do I care about this?
No.
So here's what I do from now on. Here's a little keynote. If you ever have a zero drops off, just go like this. In math, whenever you know something goes to zero, you put a diagonal line like an arrow and put goes to 0. Okay? Whenever a variable equals 0, which causes the term to become 0, just put that little symbol right there. And we could have done it over here as well, obviously. I don't want to just show you step at a time. But you can always do that. Okay? The reason I'm showing you this, and there's a reason, and it's going to come up in the next section of 2.3. Here's the reason why. If you were trying to find time in this problem, and you use this equation, time occurs here and here. So this is a quadratic function. It's like x squared plus x plus 7. You have to like factor it. If this happened to be 0, it's very easy to just get rid of it right away and then realize there's only one t left. See that the only t squared will be there? And then to solve for that t is very easy. Get everything on one side, then just take the square root. So by dropping this off in the beginning, it indicates to you that t is going to be easy to solve for, if needed. We're not doing that right now, but we're going to do it in 2.3. All right. With that said, let's plug in. We've got 1/2. What was my acceleration again? 72. Be careful, not 72. That was VF.
Per second squared. Oh, that's the
4.8. Be careful. That's all right. 4.8 meters per second squared. What's my time period? How long? And what do I have to do to that number? Good. Put your seconds there and then square the outside. Now, another thing to notice, people. Watch. When you square a second as a unit here, when you square seconds, you get second squared. Second squared and second squared cancel. You see these units here? So you're left with just meter, really. Again, this is going to become second squared once you put the square in here. That second squared cancels with that one. You're left with meter. And we're looking for x, which units should be meters. So our units make sense. Remember the dimensional analysis we did? There's a reason for it.
So when you square it, it just cancels out that.
So we have 1/2, 4.8 meters per second squared times 225 seconds squared. Because again, when I square this, 15 squared gives me 225. Second squared is second squared. Now my units of second squared drop off. Okay, both my second squared are gone. I'm left with meters. And what do we get? 540?
Yeah.
Thank you. Very good, guys. Well done. Again, not the toughest of problems, because once you take, one look at the equations you have and the things you're given, it's pretty easy to see what you need to do. Sometimes it's a little bit tougher though. What I'm going to do for the next problem, I'm going to read it to you guys and then have you just work with a partner on it, the person next to you, just to make sure that we know what we're doing. Okay? So we'll work on it together. I'll give you a few minutes and then we'll go over it together. Mom.
So the speed is the velocity, and then the length of the runway.
So this is the speed before liftoff, very good, and this is the length of the runway. Okay? Again, speed before liftoff is VF, X is the length of the actual runway itself.
So one on top of the set for
All righty, please.
How far will the baby go? If the baby carriage down a hill, the initial velocity is 0. What if the final velocity when the baby is slipstream?
Baby's body launches itself from the shoulder and lands 25 feet away.
Wait, Jack, how do we put over
Cammy, you're gonna love your speech.
You can chat quietly, but I want to see everybody writing, please. I don't see everyone writing.
I'm taking a shot.
Remember, guys, any questions about your test, feel free to ask me. And what the grading is and such. You'll notice I put how many points you got for each problem, against each problem. And at the bottom is the total amount of points you got on that. The average, I think I told you guys, was around 85, and the other section was 81.
Yeah.
You guys won the first test. Keep it up. Don't say anything you want to hear, because they're going to see this video later, if anybody watches. I'm only recording this class.
Yeah, I hate the other class,
I do it every day, guys.
Especially Dora.
Sure. Go on Moodle and look at one of the videos. Yeah, Jack, everything you say.
No audio.
So what you see is, you see the board, literally everything is happening on the board, and then you hear your own.
Do you ever play them for like Miss Coop or something?
Anybody, they're public videos on Moodle, so anybody has access to them.
I see.
I highly doubt someone's going to sit here and analyze the videos for hours upon hours.
Yeah.
Yes.
It's got a lot of
Video,
time.
guys.
You're busy, Jack, dude.
She's just trying to keep you guys safe. She's not that way cool. All right, so we got a person pushing a stroller. Pushing a stroller. Pushing a stroller from a velocity of 3 meters per
That means
second.
the initial is 3. Oh, yeah.
Constantly accelerating it at a rate of 0.5 meters per second squared. Look at your units here, please. What is the velocity of the stroller after it has traveled 4.75 meters? Maybe not as much of an applicable problem, right? Who cares is what you're going to really say. The last one, at least, we want to know if a plane's going to lift off or not. For a stroller, not a big deal. But this can be used. It's a very simple model, okay? It's a very simple model. So, I'm going to underline the key facts. Give me key fact number 1. Jeff, key fact number 1.
Oh, sorry. Well, first of all, you have velocity.
Good, number 1. So here, let's underline or box this in. Mash, give me another one. Good. Well Well done, and that's our x, you said, good, and this was our VI, as Jeff said, our initial velocity. Last one, Jeff?
Acceleration is 0.5.
Good, there's my acceleration. So a problem like this is quite simple once we analyze it. Next, what are we looking for?
Final velocity.
Okay, very good. Well, final velocity. So I'm going to box in this velocity and just put VF equals question mark for now. So take a look at the variables you've got. You've got VF, you've got A, you've got VI, and you've got X. Those are the four things, one of which you're looking for. Molly, which equation am I going to pick here?
VF squared equals VI squared plus 2AX.
Well done. Okay, work it out with the person next to you. Just go through the math, please. See what you get. I want to hear what your response is going to be because this is a problem to think about afterward. We'll discuss why. Use your calculators. You're going to need them for this one. No. So make sure you look at your units while you're doing this. This is kind of confusing, the units.
So 2 times 4.75, that's 9.5. They're all in seconds, but... Let me do this.
The units are fine to start with. It's like when you put them in the formula, you can look a little bit odd. You'll see why.
We'll see who's right.
What'd you get, Lon?
Times 0.5.
It's 13.75.
Oh, that's not what I thought.
If you have a question, please ask. I'm happy to.
So 9.9 plus 9.50 equals 18.5.
Velocity.
Yeah.
Oh, wait, we have to find our units though.
The answer is 13.75. 13.75. Some of this is man. 4.75.
You can do the 2 times 4.5. Wait, is the answer squared or
Times 4.75. So that's their final answer. No, your final answer is 189.06.
Oh yeah, I was using distributed property.
Yeah, you were. Yeah.
No, not your answer.
Yeah, 4.75 plus 9 is 13. Because you don't distribute it. How much is that?
Well, you already are given times v out squared.
Yeah.
Yes, you are. Oh yeah, it's correct. No, thank you.
Oh, yeah. Good, he's recorded that.
Alright, we'll see about this.
Okay, so.
It's 100. Yeah, but I know she's like, what?
Oh wait, that's vs squared equals.
Yeah.
Square root of 7.
Take care of the square.
Yo, do the square root of 13.7.
All right, let's go over this. A lot of you got it. I'm very happy to see that.
Yeah.
Here's what we want to notice. First, The units can seem very daunting at first here because it seems like they're off. And right away you're like, ah, well, that looks kind of weird. So let's start by doing this. We've got 3 meters per second squared. Okay? 3 meters. I saw that. I was like, what is that? That's going on. Plus 2 times a, which is 0.5 meters per second squared, times the distance or displacement. In this case, those are changeable. Okay? That's when I have to start. Now, first of all, let's go through this. When you square the 3, it becomes what, everybody?
9.
9. But what are my units now?
Meters squared, seconds squared.
Good. Again, I need to square the units there.
That's what I thought.
Okay? Next, 2 times a half is just 1. So this quantity can kind of drop off as a 1. And 1 times 4.75 is still 4.75. But you might be asking, my units need to match up. Well, take a look. This right here is, again, meters per second squared times a meter. Well, that's just going to be meters squared per second squared. Again, the units, look at your units. Meter times meter is meters squared over second squared.
So when you're adding them, it's going to be the same thing.
Whenever you're adding 2 quantities like this, when there's a plus sign, they have to have the same units. And take a look over here. Isn't this VF squared? So Garrett, why don't you help me out with the next part? Is that Garrett or Jeff? I can't even tell. Oh, okay.
That's me. And then you square it on the other side.
Okay, good. So far, keep going. How do I get rid of the square now? All right, now, here's where the unit's going to make sense, the last step. You're going to take the square root of both sides, and when you do this, you take a square root of a square over here. This is just going to become meters per second, which is what you're looking for. Now, let's remember, square root of 30% of 5. When you take a square root, how many answers do you really get? 2. Plus or minus. So let's please start by putting that out front. Okay, plus or minus.
Wait, why?
I'll explain, I promise. Alright, now, before I go further, the object, think about this, the object was doing what? It was accelerating, right? It said the object, the stroller is being pushed from an initial velocity with a positive acceleration. So the initial velocity was 3. So which answer makes sense to choose? Negative 3.71 or positive 3.7?
Positive.
How come, Paul?
How'd you get 3?
Because you're pushing it to another, like you're pushing it away from you.
Yeah, you're making it go faster, aren't you?
Yeah.
It said the problem started at 3 and accelerated. So the velocity must go up. If you chose the negative answer, it means that the velocity would go down. It would become negative and go down. Okay? So here, we have 2 answers, but what we really want to say is this. Just positive because of the scenario. So here's where you have to use your brain outside of just using math. You need to use logic, okay? Think about what's actually going on. One more question before I take yours. Imagine if you had dropped an object, so we're going to do tomorrow. You had dropped an object from the air, okay, and it started accelerating downward. What sign would the velocity have then?
Positive. Negative.
It's going down, right? So if you dropped an object from here and you found the final velocity at the bottom and you got plus or minus, you need to choose the negative answer there because it's going down.
But if you threw it up, it'll come to you.
If you threw it up, then it's going to have a positive until it gets to the top, then it's going to come back down.
Yeah, but the acceleration's negative.
Yes, the acceleration of gravity, we're talking about it tomorrow, is always going to be negative. It's always happening down. Jack,
I don't understand the whole plus minus thing.
when you take a square, for example, if I said to you, Jack, what's the square root of 25? It's 5 or it's negative 5. But just try it. If you square either of these, you get back to positive 25. So we're just looking back at some arithmetic.
Got it. Would you accept 189.06?
Would I accept what?
189.06.
You did 13 times 13.
Yeah, 13 squared.
That's not what.
13.75.
No, it's a square root of 13. Not
Square root. You squared. You did 13.75 times 13.75.
You didn't. It's
But what if it's not? Like, what if?
what if not?
There is no what if, unfortunately.
What if you're wrong?
All right, homework. Write this down, please.
It's worse than I thought. squaring them made them positive, but physically, in the situation, it would have been negative, so I didn't know whether to make it according to the problem.
Yep, that's a good question. So guys, it's a very good question. If you have a negative velocity at some point in time, and you're using the equation vx squared equals vi squared plus 2ax,
You just follow the
and you
equation.
plug it in, so say the velocity is negative 7 for initial, you do negative 7 squared, so it's going to become positive 49. Okay? The negative sign, you do normal math, as if it's normal rules. All right, I want to talk real quick. So, several things. First, remember, Friday, your problem set is due. Okay, this Friday. Now, your problem set I gave you is up through the next section, which goes into section 2.3, which is what we're doing tomorrow. Okay? Tomorrow is Wednesday. We have class tomorrow, and we have class on Thursday, both. So the problems from the last section might be a little bit tougher. So please get the other ones done all tonight, or try your best, so that tomorrow night and Thursday night, you can work on those last, I think it's 3 from the, I think there's one, I'll tell you right now. There are 3 problems. There are 3 problems from section 2.3, which is what we're doing tomorrow and Wednesday. So I'd like you guys to really, tomorrow and Thursday, to really work on all the rest of the problems tonight, so that you can hold off that last page, which is page 64, okay? Until we learn that tomorrow, unless you, and Thursday. Remember, it's due Friday. Formatting, please, again, I can't emphasize this enough. Use the same paper, okay, use a pencil, label every page with your names, problem set 1, the page number you're using. Label, please listen guys, please listen. Label every section with the problems you're actually doing. Box in your answers. List your givens like we've been doing. List the formula. Put the units in, like all the stuff that I solved the way I do in class, that's how I want to see your work done. And if you ever have trouble with that, especially go back to today's class and look how we did it today. This is a very good example of how I want to see your answers done. Okay? You do not need to write every single problem out, so you don't have to write all the words out for each problem. But list the givens, list the equation you're going to use, solve, etc., find the answer with proper units at the end. A lot of the textbook problems have annoying dimensional analysis parts, where they're given to you in like kilometers per hour, and you need to convert to meters per second. So please don't let that mess you up. Let me show you a little thing here. So everybody look up. This might really help you. And I'm okaying you guys to do this for homework. I'm telling you now. Take a look at what I did. This morning I was making a question up for you guys. And I was trying to figure out, I want to think of a real scenario, and I want it to be 55 miles an hour, which is kind of like what we travel at, right?
Yeah.
So all you got to do, if you want to convert, ever, any units, 55 mph to, and then put the units there. And it does it for you. And I can hit the drop down and change this. So if I did, say the textbook gave you,
Oh, I already found that out.
okay, so I know many of you know this, yeah, I hope you do. But let's say you had 50 kilometers per hour. Take a look. 50 kilometers per hour. And say you're doing your work and you don't want to go through the dimensional analysis of it, then you just type it in. You got 50 kilometers per hour. There it is in meters per second. Okay? This also is on your calculator. Okay? And I'll show you where that is on your calculator. So on your calculator, you're going to see it. If you go to, relax. Or maybe it's not on this one. It's on yours for sure. I know that, guys.
It's a 84 plus.
It's an old school one.
It's a TX.
There used to be
That's
someone
the
that says.
83. We have the 84.
All right, on your calculator, do you guys see the word apps anywhere?
Yeah, I go on apps all the
Okay.
time.
If you hit apps,
I go on apps all the time.
apps is located right here in your calculator, below the X. Okay. If you hit apps, after you hit apps, go down and just type the letter S, which is which is this button over here. Everybody see this button over here that says LN? Natural log it stands for, which you'll learn this year. Press that button, it'll jump down to the S category. Or maybe not. Alpha S, thank you. Alpha S. And look for side tools. Hit enter on side tools. So I'm showing you on Jeff's calculator right now. Once you've done that, press any key. Under here, you're going to see you have a unit converter of number 2. Okay, hit number 2. And if you want to convert velocity, you go down to number 6, or just press the number 6. And you want to do, let's say, 50 kilometers per hour. go over to kilometers per hour, hit enter, and then you want to go to meters per second, go back to meters per second, hit enter, and it says 1.38 times 10 to the 1. You guys see that E1 at the end? That's scientific notation. So 1.38 times 10 to the 1, well that is the exact same thing as 13.8. Again, your calculator is showing this. Okay, this is the same thing as, which in turn is really just 13.8. So you can use the converter on there. If you're at home, you want to use Google, that's fine. Again, once we've done dimensional analysis, I'm happy for you to do this. You don't have to go through the steps anymore. But I want you to know how to do the dimensional analysis at the beginning of the year. That's why I go over it. Is that clear? Okay, I'll come over and show you. And any questions besides that? All right, I'm going to stop the video real quick.